Hello guys and welcome back. We're still doing some practice on our theorems, our derivative theorems, and so we're looking at this particular problem, and it says a new robotic dog called the iPup went on sale at 9 a.m. and sold out within 8 hours. The number of customers in line to purchase the iPup at time t is modeled by the differential function a, where time is between 0 and 8. And again, ladies and gentlemen, I'm going to stress the fact that this is a differential function. So again, differentiability means it's also continuous. So we know it's continuous and we know it's differentiable. So that's really powerful. Values of A of t are shown in the table below. For 0 to 8, what is the fewest number of times in which my A prime of t was equal to 0? My A prime of t was equal to 0. So if we're looking at our problem here, we can just look at this and know that this problem is from 0 to 1, we know that we're increasing. Right? So we know from 0 to 1 we're increasing. From 1 to 2 we know that we're decreasing. So at least we have decreased between 1 and 2. So I know that on the interval from 1 to 2 my function has started to decrease. And then from 2 to 3 we're still decreasing. From 3 to 4 we're still decreasing. 4 to 5 we're being constant. From 5 to 6 we're starting to increase. And then from 6 to 7 we're also starting to increase, and then from 7 to 8 we're starting to decrease again. So if you guys can visually think about this problem, then you can now say that we're increasing, and then all of a sudden we start decreasing at 1 to 2. We're decreasing, we're constant, and then we start increasing again, and then we start decreasing again. So we know that there's at least 1, 2, 3 times that the derivative is equal to 0. So this is slightly a hybrid of IVT, right? Because again, we're not, and it's not IVT. It's not IVT because IVT has nothing to do with derivatives. But it really does have us think about where our functions are increasing, and then once it starts decreasing, we have to have a vertical tangent here. We have that vertical tangent over here. So that's a pretty straightforward example of, sorry about that little box thing, of what we need to do to just kind of visually think about this. So this example down here, I absolutely love. I love it, I love it, I love it. It says the function f and g are differentiable on all real numbers, and g is strictly decreasing. So g is strictly decreasing. Now this probably was taken somewhere on an FRQ, where if we were asking about Riemann sum, then we could talk about, whether the left or the right was an over or underestimate kind of situation. But we're not doing that question here. We're talking about these problems. The table below gives values of the functions and their first derivatives at select values of x. The function h is given by our composition function right here. So h of x is equal to f of g of x minus 6. Look at these two questions. And what I like about this is that they're so, other than the fact that this is r and this is c, they're almost exactly the same, but you do them two completely different ways. So it says explain why there must be a value r on the interval from 1 to 3 such that h of r is equal to negative 5. And then down here it says explain why there must be a value of c on the interval from 1 to 3 such that h prime of c is equal to negative 5. So I always tell students that if you're looking at this, you see something's differentiable, that's also the most important here, and that we're looking at an interval such that h of r is equal to negative 5. There's no derivative here. There's no derivative here. So I'm thinking IVT. And so let's look at it. Let's figure out what is h of 1. What is h of 1? Let's figure out what that value is first. So h of 1 is going to be f of g of 1 minus 6. So I'm going to go ahead and plug into this right here. So g of 1 is 2. So I want f of 2 minus 6. And so f of 2 is 9. 9 minus 6 is equal to 3. So h of 1 is equal to 3. Let's look at what h of 3 is. Now again, I just want us to say, just visually for a second, h of 1 is equal to 3. h of 1 is equal to 3. Let's find out what h of 3 is first, and then we're going to have a conversation about why this should make sense of what we're doing. So it's going to be f of g of 3 minus 6. So g of 3 is 4. Again, minus 6. And then f of 4 is negative 1. So negative 1 minus 6 is negative 7. So then I know that h of 3 is -7. So this absolutely makes sense. This is definitely IVT because I have to, because it's a differential function. So this function has to be continuous. Now I don't have to go straight to this line, but I have to go, so let's just do something like this. Right, there we go. So it's also a continuous function, right? It's a function. So I have to connect the point. So when I'm at x equals 1, I'm at a positive value. When I'm x equals 3, I'm at a negative value. But this says that I had to cross, there's some value of r, so this is going to be now y equals -5, right? Y equals -5 is this value right here. There's some value r on my graph that has to hit this line. So this number could have been anything between 3 and 7. This 3 and this 3 and -7. So I could have chosen any value and this would still be true by IVT. So this is absolutely by IVT. All right, so that's the idea on that. So I can say yes by IVT. I can say this. The function is continuous, so there's a function of r on the interval that applies to this. And that made absolutely no sense the way now I'm saying it, so let me just really quickly write it out for you guys the long drawn out way, but here we go. So you would say that since h of 3, which is equal to -7, so the y value is -7, it's less than -5, and that comes from this right here, which is less than h of 1, which is equal to 3. And I know the function's continuous. All right, so I know that h of x is differentiable, therefore continuous. And that's where students mess up with these problems, is that you just can't say it's different. You can't say it's continuous. You have to say, since it's differentiable, therefore it's continuous. I'm so sorry about my handwriting here. Therefore, that's supposed to be continuous, C-O-N-T. By IVT, there, ... and over here, ... exist some value of r on the interval from 1 to 3 such that h of r is equal to -5. And that just says that y has to equal -5. So somewhere on this curve, on the interval from 1 to 3, y has to equal -5. Well, if we're at 3 and we cross to -7, we had to cross -5. And again, this number here could be any value between 3 and -7. Now, what about the second part to this problem? The second part of this problem, it says, explain why there must be a value c on the interval from 1 to 3 such that h prime of c is equal to -5. So once I see the negative, then I'm thinking, okay, then this may possibly be mean value theorem. This may be mean value theorem. So let me go ahead and break this down just a little bit right here. So mean value theorem. So let's look at what the average rate of change is first. Because remember, average rate of change must be equal to the instantaneous rate of change. It'd be really cool if the average rate of change was actually equal to -5, because that's exactly what this would say. So does h, let's get rid of the f here. So does h of 3 minus h of 1 all over 3 minus 1, does that equal h prime of c? That is the mean value theorem. That's what it says, that the average rate of change must equal this. So let's figure out what it is. Well, h of 3 we've actually already found, right? It's -7 minus, we've already found h of 1, right? It's actually 3. So minus 3 all over 3 minus 1. Well, that's going to be -10 over 2, which is going to give us -5, which is equal to h prime of c. So I can now say that the mean value theorem applies here, again, because it's continuous and differentiable. Right? We've already acknowledged that. It's continuous, yes. It's differentiable, yes. So I can continue that. So this number had to be -5. This one could have been in the range of 3 to -7. This had to be -5 to let us know that there is a value of c that has to be equal to -5 because the average rate of change over that interval based on this function is also -5. So this is a really great example of just slightly modifying the problem to do it completely different ways. So again, ladies and gentlemen, as I finish out this video, I wanted to stress with you guys that if we're not prime, if it's just h of x, h of c, h of r, whatever it is, it's not a derivative, most likely, especially if you guys see the words, is there a value on the interval? There must be a value on the interval. This is the notation you're going to see, or the wording that you're going to see for these theorems. So no derivative, think about IVT. Find your endpoints and make sure this number is in between your two y values. And it should always be. And then if I give you a derivative, then it's going to be mean value theorem or Rolle's theorem. But again, why is Rolle's theorem not apply here? Rolle's theorem doesn't apply here because f of 1 or h of 1 did not equal h of 3, right? Rolle's theorem, these two numbers would have to be equal to each other. So that's why Rolle's theorem doesn't apply. And so that's the idea behind this question. So I hope you guys understood it and understand the appreciation for this question, because like I said, I love it so much. And I will see you guys in the next video.